Okay, problem number 1 says determine whether these 2 points is a solution of the system. So we're going to start with system A, and we're going to check the first point, 1, 2. Well, the 1 is the x value, the 2 is the y value, so plug in for the x the 1 and for the y 2. So this first one's going to be 1 minus 2 times 2 equals 5. That's 1 minus 4 equals 5. Negative 3 equals 5. Well, you see negative 3 does not equal 5. That doesn't work for the first equation, therefore 1, 2 is not a point that's a solution to that system. In order to be a solution for the system, the point needs to work in both equations. And the moment it doesn't work, as in this problem, you can stop. So I want to check the second point for the same system. That would be the point 7, 4. So I'm going to plug that in, 7 for the x and 4 for the y, and see if that becomes a true situation. So 7 minus 8 equals 5, and you can see once again that that's not true, so the point 7, 4 is also not a solution to that system. Okay, let's try the next system of equations, system B, and we're using the same point. So I'm going to look at the point 1, 2. Again, substituting 1 is the x, 2 is the y. So I get 1 minus 2 equals 3. Negative 1 equals 3. Again, no, that doesn't work. That's false. So I'll check the last point, 7, 4, into system B. 7 minus 4 equals 3. Well, that works, but you can't say yes that it is a solution until you've checked both equations. So far I've only checked the top one, so I now need to plug in the 7, 4 into the bottom equation. So 2 times 7 plus 4 equals 18. That's 14 plus 4 equals 18. And you can see that it works in both equations. Now you can say that the point 7, 4 is indeed a solution of the system. Okay, problem number 2 and 3. We're going to start with number 2. It says solve by graphing. State the slope and y-intercept, which means you need to get each equation solved for y. State whether the system is inconsistent or consistent, dependent or independent. Both of these equations happen to be solved for y, so the first one has a slope of negative 1/4 and an intercept of 1. So that means I'm going to start at the point 0, 1, and I'll move down 1, right 4. And I'll do that a couple times. And I'm going to connect these dots with a line as straight as possible. Oops, I didn't do a very good job there. That's a very crooked line. Let's try the next equation. The slope of this second line is 2. I'm going to write it in fraction form. The intercept is negative 3. So I'm going to plot the point 0, negative 3, and I'm going to move up 2, right 1, up 2, right 1. Not very good at drawing lines on this. You can see it does indeed have a solution. The solution is the point of intersection here. The thing is that it's very hard to tell given the way I've graphed these lines very inaccurately. So I want you now to use your graphing calculator and put both of these equations into y equals, and then remember you're going to hit second, trace, choose option number 5 that says intersect, and then you're going to hit enter 3 times. So enter 3 times. This is on TI 83 or TI 84, any of those series. So second trace intersect, enter, enter, enter. When you do that, you will get the solution 1.7 repeating, 0.5 repeating. For the graphing problem, you can leave it in the decimal values. If you want to go back and convert it to fraction form, that would be 16/9 and 5/9. Now let's answer whether this system is inconsistent or consistent. Remember, if it has at least one solution, and it does, it would be considered consistent. Okay? And then dependent or independent. If it has two different graphs, which this does, it would be considered independent. So this system is consistent and independent. Okay, we'll continue graphing with this problem, and This system, neither of the equations is solved for y, so you need to solve both of these equations for y. So 4x minus y equals 2. I want to subtract the 4x from both sides and divide by -1, which changes the signs. And you get a slope of 4, which I'll write as 4 over 1, and an intercept of -2. So start at the point -2, and then rise 4, that means up 4, 1, 2, 3, 4, right 1. Okay, and then connect the dots. Okay, did a better job with that one. And now let's graph the second line. So before I can graph it, I have to also solve this equation for y, so I'm going to subtract x, divide everything by 2, and you get y equals -1/2 x plus 7/2. The slope of this line is -1/2, and the intercept is 7/2, or 3.5. So we'll start at the point 0, 3.5, which is about right there, and then move down 1, right 2, down 1, right 2. Connect these dots. And again, we see it has a point of intersection somewhere in quadrant 1. And when you use your calculator, again, if you're using the TI-83 or 84 series, it's second trace, intersect, enter, enter, enter. When you do that, you should get the value of 1.2 repeating, 2.8 repeating. You may leave it in fraction decimal form or convert it to fraction form. In fraction form, it's 11/9 and 26/9. Again, we have at least one solution, so the system is consistent. And we have two different graphs, so it's independent.